All right, you guys, welcome back to day 2 of transformations. Today we're going to be talking about reflections. Okay, so a reflection, right in our guided notes, make sure you have them in front of you. It's when an object is flipped to create a mirror or congruent image. Okay. And then with the reflection, sorry, I should leave that there while you're still writing. With a reflection, we'll have something called a line of reflection, and this is a line that will be specified that the image will flip over. So it looks like that mirror image, kind of like how your hands are mirror images of each other. The shape will be flipped across the line. Okay. This line of reflection, we're going to draw a little picture. Okay. Let's say I have this original line segment. I'll label it A and B. And then if I had a line of reflection, let's say it was drawn right here, and then that would be mirrored over here. Trying to do my best to make it exact. So we call this A prime, B prime. Okay. So this line of reflection. This is the line of reflection right there. Okay. It creates something that we will say is equal distance or equidistant from the line of reflection. So like if this was well, 4 units away, then this would also be 4 units away. Okay, and this line right here that we just drew, like obviously we're just eyeballing some things right now, but this would be perpendicular, meaning it creates a right angle from the line of reflection to this point. Okay, so we're not drawing some weird slanted line to get there. It's just 4 and 4. Let's say if this were 7 away, then this would also be 7 away. But again, just along that straight line, that perpendicular line, great. Okay. So let's write something like that. If you can fit this in the box, great. I'm just gonna write it down here. It's the line, the pre-image reflects over. Okay. It creates equidistant points. Okay, so let's start on number 1. We're going to graph the triangle ABC with these vertices. Remember, those are the points on the triangle and its image after the reflection described. So we're starting off with the same triangle in both of these problems. Okay, so we're going to start by graphing 1, 3, 5, 2, and 2, 1, and label it A, B, and C. And it wants me to reflect over the line x equals 4. So when we're graphing x equals 4, you're going to go to the x-axis at 4, and you're going to draw a vertical line. Okay, you want to cut the axis that you're on. So if we're going to the x-axis at 4, you don't want to follow along that x-axis. You want to go the opposite way. Okay, so I'm going to switch my colors real quick. And we're reflecting across this line right here. Labeling it x equals 4. Okay. So we're going to use our knowledge of the fact that when we create a reflection over a line of reflection. Sorry, that sounded redundant. But when we transform something across the line of reflection, those points have to remain equal distant to that line of reflection. It'll just be on the other side of the line. Okay. So if we're at A right here, that looks like it's 1, 2, 3 boxes away from the line of reflection. We're gonna go 1, 2, 3 more along that same line and then label that A prime right there. Okay. So you can see that this is 3 boxes away, this is 3 boxes away. We stayed perpendicular like we're supposed to along that same line. We're gonna do the same with C. So this is right here, it's 1, 2 boxes away. So we're gonna go 1, 2 boxes away, label it as C prime. Notice how B was already on the other side of the line than we just drew on, so that has to reflect the other side of the line. Okay, this is 1 box away, so we're gonna make it 1 box away along that same line as B, labeling it B prime, and then we will connect those vertices. Okay, so it kind of makes this overlapping image like this. Really relying on that property that they are equal distant from that line of reflection. Okay, let's go to number 2. Again, we're going to start by graphing that same line. 1, 3. Oh, come on. 1, 3. 5, 2. And 2, 1. Connect. Label. A. Well, wrong one. My bad. A, B, C. Oh, that was right, huh? Sorry, I'm struggling. Hold up. Did I label that one wrong? There's no one here to correct me. Okay, sorry. A, B, C. Good. Okay, cool. We're gonna reflect it this time across the line y equals -1. So we're gonna go to the y-axis at -1. I get my line. Okay. So y-axis -1 is right here. And we want to cut the axis that we're on. So we're not following along that y-axis, we're going the opposite way. So we're gonna y equals -1, that's right here. Okay, instead of reflecting this way, we're now reflecting down. So we have to see how far away we are from the line of reflection, but down. Okay. Go back. Okay. So A looks like it's 1, 2, 3, 4 from the line of reflection. Make sure you're paying attention to the line of reflection, not the x-axis that we just passed over. Okay, 4 away from there, so then we're gonna go 4 away further from the line. So 1, 2, 3, 4. Land us right here. We're gonna label that A prime. B is 1, 2, 3 away from the line, so we're gonna go 3 more. 1, 2, 3. That's gonna be B prime. C is 1, 2 away from the line. So we're gonna go, sorry, it's hard to see where I already drew. We're gonna go 1, 2, 1, 2, right there. C prime. And then you connect. And it created an image down. My drawing's not the best because I'm drawing with a computer pen and it's not the most accurate because it's chunky. Okay, but this is what you're going for. You're going for equal distances away from that line of reflection. Okay? Okay, next page. Okay, so this one we're using the same triangle for all of them. The original 1, 3, 4, 4, 3, 1. So I'm just gonna start graphing that. Labeling them. So J, K, and L. Sorry, my eyes itchy. And this time we're reflecting it just over the x-axis. Okay, so this time the x-axis is our line of reflection. Oh, I wanted black. So just right here. And we're going to be equal distance over this line. So J is 3 away. So 1, 2, 3. We're going to go 3 more. So 1, 2, 3. Right there, that's J prime. K is 4 away. Because I can see it lined up with the 4 right here. And we're just at the x-axis. And so we're going to go 4 down. So right there is K prime. L right here is 1 away, so we're going to be 1 away on the other side, L prime. And then you connect. Next one, we're gonna graph that same original triangle. I'm gonna go graph them all right now. So if you want to skip a little bit ahead until I'm back at B, you can do that, but I'm just gonna graph them all since they're the same triangle. And then we can talk about the reflection. Okay, so just give me a sec to do that. Okay. Back up B up here. And we're just reflecting across the y-axis, so it shouldn't be too bad. Okay, and that's this line. Hopefully you never forget that ever. Okay, and then I'm gonna switch colors. Okay, and we're going this way this time because we're going across the line of reflection. So this is 1 away, so we're gonna go 1 more. K right now is 4 away. So we're gonna go 4 this way. This graph is a little blurrier. L is 3 away from this line, so we're gonna go 3 more. Right there. That's J prime, K prime, L prime. Okay, this line y equals x. This always feels a little confusing when we see this because it's like, oh, how is y equal to x? Really, it's just saying that you have a slope of 1 and a y-intercept of 0. It's technically the parent function, the most basic line of a linear function, just throws us off a little bit sometimes when we see it. So just remember, it's just slope of 1, y-intercept of 0. So we're going to create this line going straight through. It also just cuts the plane perfectly in half along the diagonal. Okay, so just like this. Okay, so it should be passing through the points 1, 1, 2, 2, 3, 3. And that's what it means when y is equal to x, that x and y values are the same in those places. Okay. All right. So if you notice on the next page, there's actually some tricks. Okay. So this one, we have this line y equals x right here. And it's harder to see that perpendicular distance because we'd have to find a perpendicular line and find that perpendicular slope to find out how far. Maybe use the distance formula and that gets a little crazy, but here's our little trick right here, okay? If we have this original point A comma B, and it's reflected across the line y equals x, which is the one we're doing right now, then then its image is the point B comma A. The A and the B, they're just swapping places, okay? So we can even write it out. So J, hold up. J right now is at 1 comma 3. So J prime would be at 3 comma 1. Okay. K is at 4, 4, and they're swapping places. So K prime is also at 4, 4. That one didn't move. And then L is at 3, comma 1. L prime would be at 1, comma 3. So if you notice that these kind of become each other and these ones kind of become each other. Okay, so I'm going to label this, it's going to be right on top of each other. So just make sure you're paying attention to what's happening. K prime I'm doing first because it's just the same spot. Go away. Go away. Sorry, I keep getting random notifications popping up. Okay, so this is K prime. 3, comma 1 is now J prime. And 1, comma 3 is now L prime. And you would connect them and it'd be right on top of the old one, but it just kind of flipped along that line. We could kind of see that the line of reflection cut that triangle right down the middle. So that one's a little bit easier to see in that case. Okay. Then we're going to do D. So D is really similar to C. It's going to be a line that cuts it right in half, but we see that -1 slope now. So it's going to be going the other direction. Still a y-intercept of 0, so it's going to pass to the origin. So we're going to cut this right along this line right here. Okay, let's see what the rule is for this one. Okay, so it's saying, so we have the line y equals -x, which is the one that we're focusing on right now. If we have our original point as AB, and it's reflected over this line, then its new, or then its image is the point -b, -a. So notice that they swapped places like the last one. We just got to make them negative, and that's because of this negative in front of the x right here. So if they were positive, they're going to become negative. They were already negative, they're going to become positive. Okay. According to this graph, these are all in the first quadrant, meaning they're all starting off positive. So they're going to flip to be negative. So let's go through like how we did it last time. J is at 1, comma 3. So J prime, they're going to flop places and both be made negative. So we're going to have -3, -1. Notice how this 1 and 3, they went to opposite places, and we made them negative. Okay? K prime, or K is at 4, comma 4. So for K prime, they're going to swap places, but they're the same number, so it doesn't super matter. But they will become negative because of that -x. So -4, -4. Okay? Then L is at 3, 1. L prime. Again, they're swapping places. So we have -1, -3. They are made negative. Okay. Okay, let's graph it. So we have -3, comma -1 right here, -4, -4 right here, and -1, -3 right there. We will connect. Okay. This one is J prime, K prime, L prime. Okay. And I just want to show you something real quick. If we were to create a perpendicular line to this line of reflection, passing through these points, so we can see like right there, going through J and J prime. Those are like the same number of boxes away, looking at the corners. So we see it's like 1, 2.5 boxes away, and then this one is 1, 2.5 boxes away. Okay. Looking at L to L prime, we can see that that one is 1, 2 box. Why is it disappearing? 1, 2 boxes away, and this one is 1 and 2. So you're kind of looking more along. Why is it doing that? I don't know. Okay. It's like looking along the diagonal instead of just like along the grid like we had been doing. And so that is kind of like how you can see it more visually if you're just trying to like transfer it over the line. But there's this special little rule that you can have that tells you where the point is going to land after the transformation. Okay. So look at the other two. So we did the x-axis already. That one was easier to just see visually. But notice that if we are reflecting over the x-axis, so we're on this one right here, over the x-axis, then the new point is a comma negative b. So they don't swap places. We're not concerned about them swapping places. But the y value is what's becoming negative. And we can see that in what we did, right? So on A, we were flipping over the x-axis. So that means we like flipped down. All these x values stayed exactly the same. We didn't shift left or right. We moved it down, which means my positive y values, they all became negative y values. So that's why your y value will become negative, or if they were already negative, they're going to flip to be positive. Okay. For this one, if we're looking at reflected over the y-axis, then its new image is negative a comma b. And again, we saw that in problem B. Okay. So we flipped over the y-axis. That means all my positive x values now became negative x values. We can see that with this red triangle over here, right? My y values, they didn't change because I didn't move up or down, but my x values did. So that's why if it's over the y-axis, those x values were the ones that became negative. Okay. And then we just talked about the y equals x line. They're just going to swap places. And then the y equals negative x, they'll swap places and become negative. Okay. On your test that'll be in a couple of days, this is going to be really important to have. So, just so you know, I will allow you to have an index card for the test, just like one side of an index card. This could be a really important thing to have on that index card, okay? So you don't have to memorize every single little rule, but you should know how to use it, okay? Okay, let's talk about a glide reflection, and then we are done for the day. Okay, a glide reflection is a translation and then a reflection. Okay, translation and then a reflection. Technically, this is a composition of transformations like we talked about last time. It's just a specific one. So you're going to glide and then you're going to reflect. And that gliding motion is a translation. Okay? Okay, let's start with this first one. We are going to graph the triangle ABC. A is at 3, 2. B is at 6, 3. Where are you at? Right there. And C is at 7, 1. Right there. You'll connect those. You will label, always label. It helps you keep track of everything. Okay, and then we're first gonna translate it, so we're gonna make it glide. This says to go down 12. And then when nothing's happening to the y, or sorry, whoops, left 12. And when nothing is happening to the y, we're not moving up or down. We're just strictly moving to the left 12. Okay, so we're gonna graph this translation first. So A is going to move over 12. I'm going to go 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Like right there. Oh, I accidentally scooted up. Sorry. You're there. Come on. Okay. B is currently at 6. So if we're moving over 12 to the left, I'm going to move 6 to the y-axis and then 6 more that way. That just kind of helps me a little better than counting every little box, and I'm counting 12 when I miss a box. Just kind of do the math of how far away I need to get to the y-axis and then how much further. Okay. C right now is 7 away from the y-axis, so that means I need to go 5 more this way, so I'm gonna land right there. Okay. Connect them, and we're gonna label it A prime, B prime, and C prime. Okay, so we did this, and now we are going to reflect it across the x-axis. So that's this line right here. Okay. C prime is 1 away from the x-axis, so we're going to go 1 more. Gonna call that C double prime. I didn't switch colors this time, but hopefully it's far enough away that we're fine with that. Okay, B is at 3, so we're 1, 2, 3 away. We want to be 1, 2, 3 more. Right there at -3. B double prime. A is 2 away, so we're going to be 2 more away right there. A double prime. Okay, so we made it glide, and then we reflected it down over the x-axis. Last one. Looks like we're starting with the same triangle again, so I'm going to graph that at 3, 2, 6, 3, and 7, 1. A, B, C. Okay, looks like our glide or our translation, nothing's happening to the x value. We're not moving left or right. We are just going to move down 6, because if we're subtracting from the y, we're moving down. If we're adding, we're moving up. So each of these points are going to get moved down 6 units. So 1, 2, 3, 4, 5, 6. What is this one? It's at 3, so we're gonna move 3 and 3 right there. Mm, right there. We're labeling that A prime, B prime, C prime. So all of those points just got moved straight down 6. Hopefully your graph turns out, your grid is a little bit easier to see than mine is on this screen. Okay. And then we're going to reflect across the y-axis. So we're reflecting across this line right here. And remember, each point needs to be equal distant from the line of reflection that we have. Okay. Lime green is what we're going with. Okay. A prime right now is 3 away. 1, 2, 3 boxes. We're going to go 3 more. 1, 2, 3. Point right there. Label it A double prime. B is 6 away, if we count them. So we're going to go 6 more for B double prime. C prime is 7 boxes away from the y-axis. So we're going to go 7 more. C double prime. Okay, and that's your glide reflection. This time we glided down and we reflected across the y-axis. And again, that's a composition of transformations. Okay. Again, you're going to have another paper assignment just to make sure that you are on the right track for understanding this material. It's really important that you guys take the time to practice. Okay, could also be a good time to start making an index card for the test that you can use on the test, or at least gather information that maybe you'd want to put on it. So then by the end of the lessons, you know exactly what you should spend your room on and what you shouldn't. Okay, but those are some good things to be working on. Again, that additional module, it's due May 20th. You need to get it done, okay? All right, miss you guys. Hope you're having a great time. And I will see you tomorrow in the video. Bye.